Hello, and welcome to today's WTA webinar, Serving the Software-Defined Market of the Future. My name is Randall Barney. I'm Executive Director for the World Teleport Association. What we do every day is advocate for the interests of teleport operators, as well as promoting excellence in their operations, their technology, and their business practices. Our webinar today is based on a report that is available on our website, and we'll be talking about that in just a moment. The Serving the Software-Defined Satellite Market of the Future report and webinar are sponsored by Kratos. We thank them for their support of WTA and our mission. WTA's research reports are guided by our Technology Advisory Board. The board was formed to address the rising challenges and opportunities that our leading members feel are really changing the nature of the game. Our board members are Comtech, Hughes, Kratos, Network Innovations, Advanced Networks, Nexat, and Skyline Communications. Membership of the advisory board is open to industry patron and leader members. If you want more information on this, please send me an email. After this introduction, we're going to cover some key insights from the published report, and then we'll launch into a discussion with today's panelists. I would also like to thank our industry leader members who make possible our research reports and webinars. They are Eutelsat, Kratos, and SES. For decades, the satellite industry had to get everything right before launch. Mission design, payload configuration, and even the business model were essentially locked in for the life of the spacecraft. That approach worked remarkably well until the communications market started moving faster than space hardware could keep up. Today, we are at the dawn of the software-defined satellite era. Software-defined satellites are changing how capacity is created, managed, and monetized, allowing operators to reconfigure payloads in orbit, adapt to shifting consumer demands, and unlock entirely new service models. But this flexibility in space only works if it's matched by equally flexible systems on the ground. Next generation ground platforms built on virtualization, automation, and increasingly AI are becoming the critical enablers of the SDS ecosystem. They're what make it possible to manage unprecedented levels of complexity, scale services quickly across multiple orbits, and move from selling megahertz to delivering fully managed integrated services. Industry forecasts suggest that software-defined satellites will soon become the dominant platform across all orbital regimes, with tens of thousands of SDS platforms in orbit over the next decade and hundreds of billions of dollars in ecosystem value at stake. Today's discussion brings together technology and service providers who are actively building that future. We'll explore what's changing, what's proving hardest to deliver, and what satellite operators, teleports, and service providers need to do now to be ready for the software-defined market ahead. So the key takeaways were SDS unlocks unprecedented flexibility and new revenue models. SDS is revolutionizing the satellite industry by providing unprecedented service flexibility and dynamic adaptability. The move away from traditional satellite platforms allow operators to dynamically match supply to demand, unlock new revenue streams, and optimize resources across multiple markets. Seamless SDS performance hinges on overcoming synchronization and standards challenges. Enabling SDS promises major technological and business advantages, but achieving seamless performance demands overcoming technical synchronization challenges, establishing common standards, and building confidence in automated operations. Ground systems evolve toward a fully virtualized, orchestrated SDS ecosystem. Ground and technology providers are transitioning to support the SDS era, redefining how space and ground systems deliver services. The transformation aligns satellite operations with modern digital infrastructure principles, virtualization and orchestration, and real-time responsiveness. Standardization lowers cost while integrated providers maintain premium value. Standardization in design and production will gradually lower manufacturing costs, leading to cheaper satellite deployments. The key financial advantage lies in lower investment risk and higher adaptability rather than immediately lower prices. Providers who deliver integrated mission critical solutions can maintain premium pricing and stronger margins. SDS accelerates satellite 5G convergence and hybrid network efficiency. As the satellite industry continues to move toward deeper integration with terrestrial 5G networks, SDS can accelerate the seamless connectivity with terrestrial operators. The next major evolution will involve moving more processing capabilities to satellites, expanding potential markets and use cases. Integration efforts are also addressing end-to-end capacity management, aligning satellite and terrestrial resources dynamically to deliver efficient hybrid services. Software-driven operations demand stronger telecom-grade cybersecurity. The transition to SDS increases exposure to the same cybersecurity challenges faced by modern telecom networks. The more parameters that are managed through software, the stronger the security measures must be. Security strategies must encompass technology, processes, and people, especially when aligning with government and mission critical standards. And finally, AI becomes the engine for SDS optimization and predictive autonomy. AI and machine learning are key enablers for optimizing SDS performance through real-time analytics and predictive maintenance. AI can support bandwidth management, anomaly detection, troubleshooting, and eventual autonomous control, though human oversight remains vital. I would like to welcome our panelists today. They are Paul Isaac, Director at Kratos, Adam Godwin, Head of Satellite at Telstra, Dr. Henrik Axelsson, CEO of Kencast, and Ivan de Beer, VP System Architecture, ST Engineering, iDirect. Welcome, everyone. Just a reminder, if you have questions, please submit them through the Zoom chat and we'll work those into the conversation. And I'm going to stop sharing and welcome everybody.
Thank you.
Thank you, Bruce.
All right, first, what is your, and this is for everybody, we'll start with Paul. What is your approach to enabling services using software-defined satellites?
Yeah, so thank you. It's great to be part of this discussion today. So at Kratos, we spend a lot of time working at the intersection of satellite payloads and ground systems, and we think as the satellites become increasingly software defined, the real shift we're seeing is not just the spacecraft capability, but how operations must evolve to keep pace. As you already pointed out, the software-defined payloads offer this tremendous flexibility, but that flexibility only really creates value when operators can safely plan and validate and execute and monitor the changes at scale. So our focus is on enabling the operational layer, the workflows and orchestration that turn software-defined satellites into deployable revenue-generating services. So the software, as we said, we give this flexibility, but the scale of that flexibility is very large. So when the number of services increase, the operations teams are not increasing to match that. So how do we put a tool in place that allows them to be able to visualize, be able to plan that, and also be able to orchestrate those services with some autonomy, so that services can be deployed through an OSS BSS tool and then drive directly to actually making changes on the spacecraft and the ground. So we want to enable operators to move from manual engineering driven changes to kind of repeatability, automated service activation.
Okay, great. Adam, at Telstra, what is your approach to enabling services using software-defined satellites?
So look, probably on a broader scale, the network itself, Telstra's global network and our domestic one in Australia, are on the journey to be more software defined themselves. What we're trying to do, and in our core, we've already done a lot of that work. We're starting to do that over partners' terrestrial networks and now satellite networks. And what it really means for our customers is a huge amount of flexibility, and that can mean turning services up very quickly and turning them down again very quickly, or emergency situations, having things go wrong and being able to change it in the back end. From the operation side, it means being able to see very deeply into our partners' networks as well as our own. So there's some real challenges there.
Okay, great. Ivan, what's ST Engineering iDirect's approach?
Yes. Well, as a ground system provider, we have to anticipate the flexibility that software-defined satellites offer. So basically, whatever is possible in terms of flexibility, bringing the capacity where it's needed, based on location, based on the user, based on the specific service that is deployed, we need to anticipate this. And currently, in the integration platform that we have, we offer global bandwidth management capabilities in a hierarchical fashion. So basically what we have is we partition the network such that different types of service level agreements can be honored. But this is in the past always been done for what I would call a fixed envelope, because the satellites offer fixed capacity across a specific location. Now this fixed envelope is now moving in towards what I would call a dynamic envelope. So it means that the full flexibility results in many more capabilities to manage that bandwidth and to align the services with quality of service and quality of experience needs for the terrestrial ecosystem as well. So we have to make sure that we manage this. And of course, this needs to be reflected within the system itself. So imagine that you have a satellite where you can move from, let's say, 10 beams, which are large, to 100 beams dynamically, or to 1,000 beams even. So this is the flexibility that we face as ground system providers. So it also means that, moving from a physical implementation of certain things towards virtualization is absolutely necessary. You cannot scale the system to the same extent as the flexibility on the satellite requires in a physical context. So this is something that we need to anticipate. And this is why we face those challenges of moving from physical implementations, like, for example, modulation and demodulation. In the very beginning, those were what I would call physical devices. Now we talk about functions that are dynamically deployed upon need. So it means that our platform offers the interfaces to control this. And Paul was talking about orchestration capabilities. So our system needs to provide the interface to allow this type of orchestration to happen. And this is a challenge, right? It's basically something that will create more opportunities for operators to deploy their networks and to offer services.
Great, thank you. Henrik?
Yeah, thank you, Randall. So we at Kencast, we provide a managed content delivery solution. So we sit before the IP, before the satellite, uplink and the ground infrastructure of that. And a lot of our customers are using multicast. That's our claim to fame. We have a very reliable multicast distribution, but we see more and more hybrid networks where there's a multicast component, but there's also a need to do individual content delivery to individual sites. And today we support that. And that's typically over a terrestrial network. So files can be delivered. Customers have a need to deliver over satellite, but also have a terrestrial component to that. And we see that there's big opportunity here where you can have multicast with software-defined satellite, and you can have unicast that can all be in the same kind of service. And we will be the front end of that. And we are quite used working through APIs. That's a lot of our solutions are deployed for system integrators. So we kind of see this as a natural fit, integrating with APIs, supporting the software-defined satellites, bandwidth, beam, and all of those things will kind of fit naturally into us. And we have a lot of products with 5G, non-terrestrial networks. I think that's something where it's going to be a big opportunity. where software-defined satellites can really help us help our customers.
Okay, great. So what are some of the advantages and real challenges of supporting this market? You could continue with you, Henrik, or?
Sure. Now, I think you listed a lot of them when you went through the details. To summarize the report, I mean, ability to do in-orbit reconfiguration, do beamforming, change that many times during the day based on the need, on demand. Just provides a lot of agility that that you need to be able to build interfaces for. I think the API-driven workflows, that's a big benefit. Of course, there's challenges in the industry. There's a lot of development that needs to support that. It's a high cost. There's a lot of innovation. Keeping up with that, it's demanding. From our perspective, as a software, this kind of fits naturally, and we already have APIs to work with this. So we see a lot more opportunities than challenges really in this market.
Okay, great. Adam, from a service provider perspective, what are some of the advantages and real challenges to supporting this market?
Yeah, look, I think we've got to be able to see into each other's networks and understand what's going on there. And obviously, we do this through software, but the more we can integrate and beyond software, the better we see each other. Essentially, the customers expect from our satellite partners exactly what they get from our terrestrial networks, or very similar performance parameters, and so we need to be able to guarantee that for them. And we need to be able to think about other things like security and make sure they're looked after as well all the way through the chain. So I think those are some of the challenges, but the reality of this this customizable bandwidth and the flexibility that it creates, and being able to look at the flow of traffic and route certain traffic in certain ways with certain parameters, it gives the customers a huge amount of options that they didn't have before.
Okay, great. Back to you, Paul. Any additional advantages or challenges of supporting this market?
The advantages, I think, have been pretty well covered today. So the challenges that we look at is not necessarily the satellites, but operations. How operations and ground systems adapt to the SDSS satellite. A lot of the systems today are pretty stovepiped. So if they're trying to understand the RF over the satellite, they're using some sort of carrier monitoring system, they're using payload information. If they're trying to understand gateway transmits, then they're looking at potentially MNC systems plus CSS systems tied to the gateways. They don't necessarily have a one place to go look at how a service is transitioning. The observability is not great right now for solutions that our customers deploy. So the real challenge for us is if we want to be able to scale and we want to automate, we need that constant validation. We need that feedback to make sure that automation actually happened. So there is some training for operators trying to understand the different monitoring points that are now available. And then there's also how do we put tooling and orchestration in place that is able to get the right type of feedback from each of the different systems that make up the ecosystem for the ground segments. Plus, as already mentioned, all of the different systems that might be feeding the gateway, whether that's a hub system, whether that is a multicast system, or even an extension of a terrestrial network.
Okay, great. Ivan, did you want to add anything to this as far as challenges?
Well, I can only align with what was said before, but I think one of the challenges is, of course, the alignment between the space segment and the ground system and making sure that this is timely done. Because what you don't want, of course, if you start to reconfigure your satellite capabilities and your ground system, that you lose traffic or that you have traffic disturbance. So a timely alignment between the satellite segment and the ground system is key, and that's something that needs to be ensured. And of course, the alignment with terrestrial ecosystems as well. Adam was talking about services, right? There is an initiative in Amplify, the former MEF consortium, where they specify a global services framework allowing service orchestration. It's basically managed connectivity that stretches across the satellite, but also through terrestrial ecosystems. If that is managed and changed, then of course the satellite and the ground system should align with that. And this is something that is part of the overall capacity management and bandwidth management. It's offering a lot of opportunities, but it's something that should be carefully done.
Okay, great. We'll talk a little bit about multi-orbit operations and global integration. Let's switch to you, Henrik. How does your solution integrate with networks around the globe?
Yeah, so we have big networks with the US government, the defense, and the way we integrate typically on a technical layout is integrate with IP encapsulators. We're the middle part between the customer who has content, files, and video to push out, and we interface with the uplink equipment. So we provide the different tools and mechanisms, how to push the content, how to schedule it, how to prioritize it. Does it go over satellite? Is it a hybrid network, terrestrial? And in terms of multi-orbit, there could be a lot of different benefits in terms of how this is done. Multicast over GEO, MEO maybe, unicast over LEO. How does this all fit together? It's not quite clear yet, but it's certainly provides a lot of options. And I guess the big challenge here is really, yes, the satellite, there's the ground infrastructure, but how do you make applications? How do you present this to the end user so you can fully utilize all these functionality that's made available?
Okay, great. Adam, how does your solution integrate with networks around the globe?
So Telstra runs a huge subsea network, mainly focused in Asia Pac. And, if we think about how we want to integrate with our access suppliers, and we've started to think more about our satellite providers as access suppliers to essentially give us the same access as a terrestrial local access provider might do in say Japan, that will take a service to Australia. We've started to look at satellite like that as end customer access. We want to basically have as many points to integrate to them as possible. So if I look at some of the big providers to us, we will integrate with them in most of the markets that we play in, because it strengthens the bonds between our networks. I think as many places as possible is sort of the very simple answer. I think we're also connected with hundreds of other networks, so it's sort of for our end customers, our value is meshing that together and making sure that their traffic flows smoothly all the way along that, and that's not a simple challenge.
Okay, great. What new opportunities are unlocked by SD satellites operating across LEO, MEO, and GEO? Paul?
So I think the multi-orbit operations, they unlock some service resiliency and service agility. But obviously it does require that coordination. So with the software-defined payloads allowing that dynamic allocation across the orbits, but the orchestration problem becomes a little bit more complex because we're required to manage timing, required to manage handovers and performance. The tools will need to help the operators plan and execute those changes coherently, rather than treating each orbit as a silo. And this opens the door to kind of hybrid service, dynamic routing, improving quality of experience. Definitely service resiliency has got to be one of those major points. But obviously there's different types of service offerings where they may want to use bandwidth with lower latency to support particular use cases. and then using SDS for some of the geo satellites for some of the ones that are more tolerant of the latency.
Okay, great. Ivan, what new opportunities do you see unlocked by SD satellites?
Well, I think formerly what we saw was that LEO or MEO or GEO networks were rather isolated. They were all GEO or all LEO. And I think combining the features of each of those is going to be key. So it means that from a ground system provider perspective, we need to make sure that one ground system can offer connectivity to all the orbits. And indeed, it comes with challenges because you need to provide handovers, you need to make sure that timing synchronization is properly done. But it's something that we definitely go for because we believe it's important, because making sure that you can select the proper path for the proper service is something that our customers will benefit from. And what we see is that our customers typically will have more than one orbit in store. So it's not that they only are a GEO provider or they only are a LEO provider. We see this gradually being combined. And they are thinking along those lines of, for example, having a broadcast service over a GEO and data services over LEO, depending on the latency requirements that they have or depending on the quality of service requirements that they have. So being able to anticipate this and have the proper bandwidth allocated, I think is going to be key for ground system providers as well.
Okay, great. Henrik, how quickly can services scale as constellations grow or traffic spikes?
That's as a software provider, we kind of lean on the ground station operator satellite to kind of answer that. But from a software perspective, that's the easy part, I guess. It's able to scale very quickly, and we've seen many use cases where unicast deliveries can benefit from multicast load if the networks get busy. DBNIP is one good example where we have a lot of people watching a stream. You can transition over to a multicast, and that's supported in a standard can happen autonomously. And we're working with some people in that area. And I think the key thing here is really good API integration.
Okay, great. Thank you. Moving to cost and pricing models. Paul, I don't know if you want to take this or anybody. How will software-enabled satellites affect cost and pricing for services?
I can take a stab. I mean, the software-defined satellites will shift costs from hardware to operations and software. It has to change the dynamic. The opportunity is a lower marginal cost per service, and that's essentially where the satellite operators need to get to, right? They're trying to compete in the industry right now. So they need to look at ways of doing that, and the only way that they can really do that and leverage the SDS is with automation is introduced. Otherwise, if it stays the current way, which is very manually driven, then operational costs will increase to support that. So our role at Kratos is really helping operators reduce that cost to serve by automating the configuration, automating the validation, and automating the execution workflows. So hopefully by adopting solutions like ours, they would be able to keep the costs under control and be able to increase the number of services that they're able to offer.
Yeah, I think I can add to that. First of all, I think software-defined satellites give the opportunity at least to optimize OPEX costs, because if it's done properly, the bandwidth and the capacity that the satellite has is hardly ever underutilized, because you can make sure that the beams are there where the need is. So it means that you can make more optimal use of statistical multiplexing across the globe. So that's one. Secondly, when you take a look at virtualization, and this is also OPEX cost, if you align the capabilities of the satellite with the ground system deployment in a more dynamic fashion, also that will result in the reduction of costs over time, right? It's something that operators will have to invest in, and it's indeed linked to operations. What we also believe is that it will allow also capabilities for operators to differentiate services. For example, if you take a look at 5G, and I see some commonality there. 5G offers a new concept they call network slicing, where they have potentially different slices for different types of services or markets. You can have emergency services, you can have broadcast services in different slices, and they are protected in terms of bandwidth. On satellite, it can be the same thing. So you can offer high-paid services, you can differentiate them, and you can give the capacity that they need. And you have many more means to anticipate congestion there, because you can intervene by changing the capacity on the satellite itself. And you can have ways to manage the congestion in a more flexible way. So this will give the emerge of new service models, we believe. And that's something that we need to facilitate as well from a ground system provider. And then, of course, last but not least, yes, automation. But I think there's a lot to mention about automation. I think this is one of the further topics to discuss.
Okay, great. Continuing on pricing, Adam, what are the main cost drivers for customers?
Look, in some ways, you know, we've seen the success of LEO and it's drive the cost down, and you know, a very low cost to serve in certain scenarios. But what we also see at the same time, and I think some of the other panelists have touched on this, is that there is a potential premium here as well. You know, and it's not just like emergency scenarios where we need the bandwidth, which might be a natural disaster. It might be for us, a cable system going down is a fairly common occurrence. And so certain traffic types, you know, are definitely premium, and they would be prepared to pay extra for a short amount of time to have that traffic continue to route. And so, you know, there are, at the moment, it's hard to dynamically do that. At the moment, we set up fixed satellite solutions that are only occasionally used as backup. And that's the reality there. But with software defined, we can obviously route much more intelligently in those sorts of scenarios, and we can choose our traffic types, and we can be very prescriptive about that, and we can route quite dynamically. So I think you know, there's much higher utilization potential for the satellites. You know, so there's a sort of win there, but there's also a win with premium traffic. And there's a win with the overall cost to serve, and the bandwidth itself should go down. So yeah, that's how I think we see the pricing sort of coming out.
Okay, great. Anybody else on cost and pricing before we move on to operations?
Just to add that, you know, today our customers, it's long-term contracts, and that kind of goes through the whole value chain. So we have long-term contracts, that's kind of fixed pricing. We see that changing to, you know, last couple of years has been more subscription-based, but we can very well see that it's going to be software as a service, where it's completely deterministic on how much you're using. That's probably a shift that's going to come. And also, we're talking a lot about the links, but also the ability to actually do computing on the satellite. There's a lot of use cases, defense for sure, where I could see a lot of need for that. And there would be premium services for sure. And that's something we're talking to some people about. And I think there are going to be new pricing models. There's going to be a lot of need for kind of determining what works for customers, and that will be a determining factor who succeeds. Just the business model around it.
Okay, great. All right, shifting to operations and cybersecurity. I have a question from the audience here. Is there a firewall between satellite control and software-defined manipulation that gives third-party teleport providers the opportunity to dynamically make changes on satellites that have traditionally only been done by the operators themselves? What are the limits on third parties?
That's I can take a little bit of a stab at that, having worked with some of the control systems for the modern SDS. So there is typically a single interface to configure the spacecraft. There are, obviously, with the prices of the spacecraft being so high, there's CondoSat is a thing now where there's multiple operators operating exactly the same satellite. And essentially what you see is a couple of different ways of doing that. There's either one common component that's driving the configuration, so effectively understands the payload data model of the spacecraft. Or they may actually have two separate ones and they've kind of done a split of inventory across the two devices. For an external third-party teleport to operate, there are some solutions where a connectivity between like a SATCOM NMS, for instance, can kind of like make request changes to the bandwidth, and it was mentioned earlier about being a fixed envelope moving to somewhat of a dynamic envelope. There is the ability to have some of the feedback loops in certain types of the satellites that support that. But that has to be on a case-by-case scenario. For third-party teleports, we see the ability to take a workflow through the solution. So, for instance, if you have a capacity request and you have a particular landing zone where your teleport's operating, and you have a landing area where your end customer is operating, you would create a service request that you would feed that directly to the satellite operator. That will get processed and validated. If the current configuration of spacecraft can support it, then it could be orchestrated and changed, but the operator would be in control of that. But it could be, it's an API loop. So essentially, by making the request, you go in and it's all machine interface changes from the validation of the plan that you're requesting to the current configuration and to any adjustment that might be made on the satellite. These things aren't necessarily real time, especially if you're requesting new beams, because they have to go through the math of the beam forming, and they're still working out how long that's going to take. So it's probably a request and then a wait for the response to make the change. So there's still some planning that has to happen. But if it's a route that's already been pre-configured, then that's a pretty simple gain change or gain state change. So that channel that's already been configured through the spacecraft and is known, then it's just a case of turning it on and off. And we see that through the API control. And it would be, we're definitely seeing value customers within a satellite operator requesting their own planning tools that allow them to send an automated request through the satellite operator systems and directly to the spacecraft to make changes. I think it will be a little bit of a walk before run as people get comfortable about the type of spacecraft changes that need to be made. You know, we're going from a world where we plan transponder changes over weeks, and then we carefully monitor those changes, to now a scenario where we're driving it based on demand. And so operational tools need to come online to be able to say, what's the approval process? Is this supported? How quickly can we do this? And what's the validation and steps that are required when we actually execute? So I think that as we talk to our customers, they have a roadmap of how they do the automation, and this will take some time to build out.
Okay, thank you. Ivan, do you want to talk a little bit more about operations and orchestration?
Well, I would like to address the firewall.
Oh, sure. Go ahead.
Because, but it also links to operations, obviously. I mean, if you take a look at cybersecurity in general, firewall is just one aspect of it, right? Basically, what you need to do, and this is for the payload on the satellites, as it is for the ground station, equally important, is you have to protect those systems, because potentially that's an attack surface. So you have to make sure that the only person that connects to the payload or that connects to the ground system is the one that is allowed to do that. If there's an orchestrator that controls the ground system in order to be aligned with the satellite segment, that should be protected and that should be authenticated and authorized. So we have to make sure that all the cybersecurity aspects are properly guarded. And this is, it's not specific for software-defined satellites as such. in general, I think cybersecurity practices span beyond product security only, because the attack surface can be well within our own company, right? So you have to train people, you have to give them awareness, you have to make sure that there are proper coding standards in place, that you have the proper pipelines. But not only that, if you do software upgrades, and that's more to operations and logistics, you have to make sure that those images are properly signed before they get deployed or encrypted even, depending on the market. So you have a vast way of protecting your systems, right? And this is something that becomes more and more important. And of course, communication security is equally important. You have to make sure that the communication channel itself is encrypted. And depending on the market, the more severe you have to make this, right? Up to even Transec. When it comes to interaction with the orchestrator itself, yeah, in what we try to achieve in the end is a zero trust model where everything is basically properly guided and properly secured, authenticated and authorized. So there's a lot to say about this. Zero trust is not an easy concept. It needs to be introduced in steps. And of course, during operations, security is not always the most easiest thing to cope with, right? Because it often blurs troubleshooting, and sometimes engineers are not fond of this, but it's absolutely needed in the market that we live in. And continuous monitoring is equally important, right? You have to make sure that if something happens, regardless if there is a breach, that you detect this as soon as possible. So from an operational perspective, yes, security is basically something that pops up everywhere now.
Okay, great. Henrik, you want to talk a little bit about cybersecurity?
Yeah, so for us, not that much has changed. You know, we're a software company. We have government contracts. It's a lot to deal with, as Ivan said. That's all different touch points. We're not operators, but we're software providers and hardware providers. That's FIPS. There's all kinds of different things there, but we don't see that changing that much. We just with software-defined satellites for us, and that's in all kind of different markets. It's defense, it's commercial. We distribute Hollywood feature films, and security is at least as strong there. At least they want it to be at least as strong as it is in the government. So it's across all different markets. Just to add that.
Okay, great. Adam, what is your approach to cybersecurity at Telstra?
Look, I think security is incredibly important. We like to try and design all of our products starting to think with security as first principle, and seeing as far into our partner networks and products as possible, so that exactly what the other panelists have talked about, we are going to have an attack surface there. We like to think about software defined offers different ways to manipulate the network for attacks, and so we want to think about that as well. What potential opportunities this gives to attackers, but before we start to even offer a product to our customers, before we put it out into the marketplace. So we would like to think that through beforehand. We need partners that follow our policies very closely, and obviously that where we're a partner to them, we would hope to be a very strong security partner as well. It's key, and we think about cybersecurity from the ground up. I think some of the other panelists have covered more of the specifics.
Okay, great. Paul, did you want to add anything to your approach to cybersecurity from the Kratos perspective?
Yeah, I mean, just to echo what you said, all our software is built based on the principle that we have to secure it. So we obviously have the encryption with the interfaces. We see to connect to the firewall that's between us, the orchestration layer, and the spacecraft. We have to adapt to the secure interfaces and control mechanisms that are supplied by the manufacturer. There are, on all the projects we're working with, a lot of security requirements around how we do the deployment. Our customers are very serious about this, so all of our software from the ground up is built with security in mind. It's not a feature. It's it's absolutely a base level that we're required. We're also using role-based access control as well to make sure the right users get access to the right areas, and not just allowing blanket operation inputs. So it's definitely a very important element that we see in building out the solution. And it needs to be to be able to protect the assets from all the different entry points that are required for automation.
Okay. All right. No conversation is complete without addressing AI. So what is and we'll start with you, Ivan. What is your roadmap for supporting AI and machine learning as it pertains to
AI is
SDS?
indeed important, right? And everybody is talking about it. But there are different aspects to AI, right? So the first thing is if you talk about software-defined satellites and the capabilities they have in changing bandwidth on the fly, the first thing you have to do is try to detect what the traffic patterns are that you have to anticipate, right? And this is something that AI really can help in, because in general, AI is good in pattern recognition, right? It basically can predict certain things. And what we believe is possible is that if you interact with the system and change the bandwidth, is to move from a reactive approach where you detect certain things and you anticipate them to a more proactive approach where you know, okay, we see this happening every month, or we see a specific pattern or a need over a specific area every week. So these are things that AI can facilitate and can then drive the orchestration of both the satellite segment and the ground system, right? And that's one aspect. It's basically anticipating traffic patterns. In the end, what I believe is it can also result in business flow automation, and service orchestration needs. So you see that AI can be brought in different layers, where basically the learning about the behavior of the system results in a proactive reconfiguration of those systems. Next to that, AI, well, if you talk about AI, often they also talk about large language models. Those can also help in interacting with a platform. It's not specific for software-defined satellites per se, but it's a means to allow an operator to interact with the system, to have an learning about the interaction schemes and anticipate that. So you see AI and machine learning can improve the way we cope with our systems in different fashions.
Okay, great. Paul, do you want to add to that?
Yeah, I think I agree that with Ivan, it's definitely a very layered approach, depending on the different areas that he can help with. Certainly from our discovery and roadmap, we already have a history of looking at this to predict things like failures. So based on the kind of like history and trending, we've looked at predicted failures. We're looking also at predicting configuration conflicts and optimizing scheduling, as Ivan mentioned, around the orchestration layer. And then we think from an operator perspective, yeah, there is definitely a fit there for the large language model. Rather than having to search for information, ask the question. If the customer calls in, tell me all the services that this customer has and where are their entry and exit points within the network that I operate. Being able to derive reporting from prompts would help with keeping your headcount lower. But I agree that it's not really specific to SDS. It's more of the help desk, support, those types of roles that help the companies keep their bottom line in check.
Okay, great. What investments or upgrades are you making to stay ahead of SD satellite evolution? And we'll stay with you, Paul.
Okay, yeah, well, we're definitely investing heavily in our orchestration frameworks and scalable workflow engines, but also performance analytics, so that I can operate across multiple satellites and ground systems. Our goal really is to support that increasing payload complexity without increasing the operational burden. And that's just one area of Kratos in that area. There are many other areas with our flight systems and also our modem technologies as well. So we definitely have a lot of investment that is geared towards the SD satellite evolution. We see lots of different areas and lots of different opportunities where we can help our customers maximize the revenue they get from their spacecraft.
Thank you. Adam, on Telstra, what investments or upgrades are you making?
So we are introducing what's been termed our network as a product. So what this really means is a lot more software and making all of our infrastructure really available through APIs. And having that as the driver of using the network. But it extends beyond that into our partner networks and into our partners' satellite networks. So this idea that you can utilize anything that we have, but also anything that our partner has as a customer of ours in a fairly simple interface. It seems simple, but it's really quite a long journey for us and our partners. But that's where we're headed. In terms of some of the other things that we might do, so we might look at the quiet zones in Australia, because really the newer satellites are driving different frequencies, and for us that means there's certain areas in Australia, for example, where you can use any frequency at a very low cost. So those areas become a lot more attractive for some ground infrastructure, for some scenarios. So that's some direct investment that is related to this.
Great. Henrik or Ivan, do you want to add to that?
Yeah, it all depends on what is the end goal. If you take a look at 3 to 5 years from now, what is basically the goal that we put forward? And it's basically automation, right? Making sure that an operator is taken care of. Basically, the platform should do whatever it can do to facilitate operations. So automation is key. And for that, we invest a lot in making sure that we collect the proper statistics from our platform, that we can feed that into engines that are AI driven, making sure that the steps that we take will result in that end goal. So zero touch operation is the end goal. Of course, it can never be completely zero touch, but I think we can come close. And the software-defined evolution is facilitating this largely, right? Not only software-defined satellites, also software-defined networking. When you bring all these pieces together, you can really go a long way. So that's basically what we aim for.
Great, thanks. Henrik?
Yeah, and adding to that, going back to the AI, I think it's so we're a content delivery software, and there's many different ways to route content. There's different algorithms we can apply for. It's called forward error correction. And based on the feedback use data, based on priority of files and videos and streams and the overall network condition, there's a huge amount of data for operators to process. I think this will really be a step-by-step kind of evolution to present it based on machine learning, to then make decisions maybe based on machine learning, and then we see AI coming in after those steps have occurred, really. So we're spending a lot of time working with existing customers. We're working with a lot of satellite operators to kind of wrap our head around all of this, and also being part of industry and the standards organizations to be on top of this and help influence what we see as a good solution in that.
Great. Final question, final thoughts. Adam, we'll start with you. What capabilities will service providers need in the next 3 to 5 years?
If we think about talking across each other's networks, the standards, and I think we touched upon like Ethernet and MEF, or those sorts of standards are going to be important, that we can automate well between each other, really see into each other's networks and understand what's going on, whether that's inventory or whatever it is. There are loads of challenges there when we talk about satellites that are different from terrestrial networks. We're going to need all the APIs to flow very simply through each other's networks. None of this is super simple, but hopefully the interface will be really simple, whether it's a human on the end of it or indeed a machine that's trying to interact with the network.
All right, Paul, capabilities in the next 3 to 5 years or standards?
Yeah, I think we already touched on a lot of them, but automated payload workflows, the cross-domain orchestration, just mentioned, the real-time performance visibility across all of the different subsystems, integration across the multi-orbit architecture. The goal would be that closed loop optimization, and whether that is rules based or whether that's AA based, that's just a factor of time and kind of the intent. You know, the point that we see is flexibility without structure increases risk, but flexibility with automation that creates opportunity. So by introducing those standardized workflows, orchestration, performance, visibility, the operators can really fully realize the promise of the software-defined payload. And you know, Kratos, we see this as a journey. 3 to 5 years, it's definitely a journey, and we want to be able to enable operators to adopt these capabilities at their own pace, while building towards more agile, scalable, resilient satellite networks.
Okay, great. Henrik?
I would say it's going to be more and more convergence between satellite and terrestrial networks. And one of the capabilities we think would be important is workflows for different kind of end user applications. How will they map to what the software-defined satellites can provide to realize all the benefits?
Okay, and Ivan, final word.
Well, we have to make sure that this convergence happens. And we see this across multiple types of radio. We see 5G NTN entering the satellite ecosystem. So basically what we need to do is, from a standardization perspective, is facilitate that convergence. And this is something that the telecom industry will benefit from.
All right, great. Thank you very much. Thank you to all of our panelists today. Coming up, Satellite 2026, March 23rd to 26th. We have our Teleport Awards luncheon on March 24th. I hope to see many of you there. Upcoming reports, we have our new markets to watch, how executives are planning for the future, due out in late March or early April. And thank you all for attending today's webinar.